So we talk about time series analysis, decomposition of a time series into its various components. So as we know, any time series data will be a combination of four components, essentially four components, namely the trend, the long-term movements or direction, the seasonal variation, a repetitive movement over a short period, that is, could be during the week, during a year, like monsoons, for instance, they follow a particular pattern which repeats every year. Then you have the cyclical variation, which is a long-term variation, where from one the variation can be from for a very long time, and these also are called as business cycles. These are also called business cycles, and it's useful from a business point of view. You can even see the stock market will have long-term cycles. The commodities will have certain long-term cycles: gold, oil, silver. And then, of course, the fourth component in a time series data is the random component or the irregular component, which is the component which is due to the volatility in the series. So every time series data would have certain amount of volatility, and that volatility is captured in the random. So now we will estimate each component one at a time. So basically, time series data consists of all these components, and they have to be estimated one at a time. So first you estimate the trend, then you estimate the seasonal component, then probably estimate the cyclical variation, and then you probably estimate the random component. So this is called time series decomposition. So essentially, when you do time series decomposition, you estimate the trend, the seasonal, and the random. So these three are clearly captured. And the residual is called the random variation. The residual is called the random variation. Which is analyzed using a different method. We will not get into it right now. If you want all these components to be estimated and then put together, it is very effectively put together by a model called the Holt-Winters triple exponential smoothing model. So to put all these three components together and then use it for forecasting, we normally use the Holt. To identify what are the long-term cycles in a data, you use a technique called the spectral analysis. And once you've identified the cycle, you can model that cycle and see how it behaves using harmonic analysis. So there are two techniques that is used here. One is called spectral analysis, the other one is called harmonic analysis. So spectral analysis is ideally suited for identifying cycles. But the only problem that you should remember is when you're trying to identify a cycle, you need a very long data. So whatever cycle you may identify may not be very, reproducible, may not be real, and it may just be a cycle by chance. And in such cases, you need long series of data. So to understanding these tools equips the researcher and practitioner to extract meaningful insights from the data and make more informed decision making. So even when you talk about time series, when you talk about this time series data, right? When you talk about time series data, you have two types of models. One, you have the additive model, which combines the trend is added to the seasonal component, is added to the cyclical variation, and is added to the irregular component to get the overall data. So this is called the additive model. The multiplicative model is the one where the trend is multiplied by the seasonal component, is multiplied by the cyclical component, and then multiplied by the irregular component to get the sales. So to estimate the trend, we normally use either moving average or we use a regression. Okay, so once a trend is isolated and removed, then you can estimate the seasonality. The method that you will use, the common method that is used to estimate seasonality is called the ratio to moving average model. Ratio to moving average models. We're not getting into it. We're not getting into it because the program will do it for you directly. So you should only know how it is to be estimated and how it is to be interpreted. So once the seasonal component is estimated, we then remove the seasonal component, and what is left is called the residual variation. So this is or the residual or the random variation. So this is what is called as decomposition of time series data. Okay, this is called decomposition. So once these three components, that is the trend, seasonal, and cyclical variation, trend, seasonal, and cyclical variation are estimated, then we put them all together. In a model called the Holt-Winters triple exponential smoothing model. Now, Holt-Winters model consists of three parameters. One is the level. That is the average value of the series. The second one is a trend. You would have estimated one trend. So that trend is incorporated into this model. And the third component is the seasonality. So what Holt-Winters model does is it estimates all the using exponential smoothing, triple exponential smoothing. It factors in all these parameters, mainly the level, the trend, and seasonality, which is referred to as alpha, beta, and gamma. Now, alpha, beta, and gamma take values from 0 to 1. On the lower side, it's 0. On the upper side, it's 1. And now the computer normally decides these values. So what it does is, if you take a value 1, it means that you're going to consider the recent, give more importance to the recent seasonality, the recent trend, and the recent level. If your value tends towards 0, you're spreading the effect over a longer period. So you have to, as the alpha, beta, and beta and gamma becomes 1, then you're going to use recent values, not extended values. If your value tends to 0, then you're using a larger window to estimate these 3 components. Okay. And then, of course, finally, we have the spectral analysis. Spectral analysis, which is used to identify cycles, also a very useful technique. Spectral analysis detects cyclical patterns by analyzing frequency components. So it converts the time domain into frequency domain. It converts the time. The data is now arranged on time, no? 1980, 1981, 1982, 1980, like that. But it converts into cycles, long cycles, medium cycles, short cycles, and then finds out which is the dominant cycle. And that is essentially what spectral analysis does. So the spectral analysis, in order to estimate it, uses the fast Fourier transform. It's called the Fourier transform or a periodogram to convert the time series into frequency domain from the time. So this is what it does. And to identify the frequency domain, it's quite simple. It is just 1 divided by period gives you the frequency. 1 divided by period gives you the frequency. Okay. Once you've identified the frequency, once you've identified that frequency, it could be a 6-month cycle, a 2-year cycle, a 30-month cycle, a 42-month cycle, whatever it identifies, then that cycle can be modeled using harmonic analysis. So once the cyclical periods are known, fit a harmonic regression model using sine and cosine terms model. So suppose you have one frequency, then how you'll estimate is yt is equal to beta 0 plus beta, like a regression. Sine 2 pi, that is 100, pi is 108, so 360. So 2 into 1 pi into f. F is 1 by period. F is 1 by period. So we are talking about 40-day period. So it will be 2 into 180 divided by 1 by period. Now it will be by 40 into t. T will take 1, 2, 3, 4. Similarly, you do for cos. Supposing you have multiple frequencies, then all those frequencies can be accommodated. Okay, you'll have sine, 1 sine and 1 cosine for each frequency. So you'll have 2 pi ft, that frequency will be different, plus beta 2 cos, plus beta 3 2 pi f dash t, plus beta 4 cos 2 pi f dash t, like that. You're going to have many terms in the model. And that is what I'm going to demonstrate to you, right? Okay, so time series decomposition is what I'm going to show you brief. Okay, here we go. So we have a same data. I'm using the same data that we used earlier. So I'll just run through that so that you don't get any confusion. So first, I import these regular pandas for importing data, numpy for manipulation, matplotlib.pyplot for graphs, and OS for setting the workspace. Then we go down. Right? Then I set my folder, OS change directory student. I told you I've got 3 files which I read one individually, and then I pull it together into a new variable called exchange rate. Then what I do is I exchange rate dot duplicates dot sum. I remove the duplicates, right? I remove the duplicates. Here I drop duplicates. Then I check whether there are any duplicates, and it says 0. Then I take the size, like I say, shape. No, when I say exchange rate, exchange like ex underscore rate 1 dot shape, it gives me the shape of the first file, 4,999, 7 columns. Second is 5,000 into 7 columns. Third is 1,845 into 7 columns. And overall is 11,000. Some total of all these 3 will be 11,670. Okay, so I'll just have a look at it. You can see it's a little jumbled up. So it's starting from 1999. And then here what I do is I say rate info, and I notice that the date is not in a date format. And when you're using time series data, please ensure that the date is in date format. I change the date variable by saying PD2 underscore date time, name of the variable which I want to convert, and I say format is equal to mixed. And then now when I check the rate, it is in the date format. It is in the date format. Then what I'll have to do is I'll have to export. You see, it's starting from 1999. And the time series data is a chronological arrangement of data. So I arrange the data by saying exchange rate dot sort values date. Then I take only these first two columns because I'm not interested in the remaining columns. So I take 0, 1. I use an iloc, open a square bracket. Colon, comma means all the rows. And I put a bracket and say column 0 and column 1. So that it does. Then I reset the index because I need to have the index clear. And then when I look at the date, I find that it is 79. It is starting from 79 because I've sorted it. I've sorted it, right? So that has to be done. Now here what I do is, now just to give you a brief background, what I did was the data, this particular data is 5 days in a week. So if you don't tell the computer that it's 5 days in a week, it will take Monday and Tuesday and make it Saturday and Sunday. It assumes that there are 7 days in a week. So if you go to ChatGPT, it will tell you this. This is the frequency beta means it takes only weekdays. So you can just, I will keep this codes. You can just carefully study the codes. I won't get into the details. So it says from the lowest value till the maximum value of the index, create a database with only weekdays. Okay. And then I tell it to create reindex a figure, and I say a reindex data range. And I put the index name as date. And now I get a nice index which runs continuously from 26/12/79 till 24/1/25. So, like for instance, if there is a missing date, it will show it as a not available, NA. So then what I will have to do is I'll first check how many missing values are there. I find there are 116 because these will be holidays over the last 20, 30 years. Then what I do is in one step, I can interpolate them. I just say df is the name of the file, dot interpolate in place is equal to true means it will remain for this session only. It will remain for this session. And then when I check the null values, I get no null values. I'm all set. So I now call it exchange rate underscore T. I call it df as exchange rate underscore T. Then I plot it. And now I will show you the remaining part of the work. Okay, now we're going into time series decomposition. Very, very easy. It's very, very easy to do. So import pandas, import matplotlib, we have already done it. And import statsmodels.tsa.seasonal, import seasonal decompose. You can't remember it, you have to go and get it from the net. So now it can do this, what I told you, 10 seasonal cyclical random variation, one shot. So since we are working with daily data, now the data that we have so far is daily data. Now I want to convert that. If I want seasonality, I should have monthly data, or I should have maybe quarterly data, or maybe I can even do it weekly. But I'm going to convert it to months. So I call it exchange rate month, DF is the original data, DF price, resample M means it will convert and it will make it the mean. It will make it the mean. Okay, it will take all the means of that month and it will aggregate. You can also show last if you want. Okay, so what it does is it will calculate. And then what I'm telling in one shot, I'm telling the computer saying, also interpolate the values. In case there are any missing values, please interpolate. Fill in the missing values. Okay, then check the type should be a panda series and print the index. And then with one shot, your analysis is done. Please see, the name of the output is result. Seasonal underscore decompose, name of the file exchange rate, x rate M, model is equal to additive, period is equal to 12 because it's monthly data. Results is equal to plot. So when I run it, there it is. Yeah, here it comes. So all the 4 components, you get it in one shot. So this is the original data. So the trend, this is it's just the trend from the data is estimated the trend. And once a trend is removed, he's estimating the seasonal component. And once the seasonal component is removed, the residual part is called the error. Now, the problem with this is seasonal component. Now, seasonal component, what I want, since it's monthly data, it tells me how this exchange rate, Indian exchange rate versus dollar, is behaving in the 12 months. So it repeats every 12 months. So in order to highlight that, I say plt.plot, results is the name of the file, results is the name of this file, results dot seasonal, component is seasonal. I want from 0 to 12. It'll give me 1 to 12. And x6 is rotate 90 degrees. I want it vertically. Okay, so what I do is I run it. And this is what the season. This is very important for me when I do time series decomposition. So what it tells me that the exchange rate is the lowest. Exchange rate is the lowest, meaning exchange rate is the strongest. Usually the exchange is very strong in the month of May. And then the exchange rate starts decreasing. Going up means it's getting devalued. So in the 9th month, it will get devalued. And then it will remain there in the business. So it gives me the pattern, how the Indian exchange rate versus the dollar, how it changes. So it becomes strongest in the month of the 5th month. So how did I get it? By highlighting only the first one. Right. So now that is done. Now let me tell you, I have not given you the trend. We have not estimated the trend, right? So I want to find out what is the trend. Seasonal component, I found it. Okay, I want to find out what is the trend of the series. Okay, so this is all done. Seasonality is there, I'll put it above. I want the trend of this. Okay, so as we know, trend is a regression. Okay, so it will be import stats models dot API as SM. Okay, we've done it before, so I can just show you that. So, okay, SSM and model rig trend. Trend is equal to SM dot OLS OLS yeah, here it is. This is a command. I'll get the regression. I'll take this one. Okay, so there'll be no confusion. Okay. Stats models. That is already there. Okay. Exchange rate is price and constant with time. SMS, OLS, now this I don't require. Now this. Okay, this is all. Okay. Model, model of it, and model dot suffer. Okay. So what you're supposed to do is, please note. So I first import this stats models. Then I define the y. Y is price, x is time, and I should add a constant for intercept. And then I fit the model with sm.ols, y, x, y is this, and x is capital X, fit, and a summary. So let's see PI. PI. see, so there's nothing there. I convert it into a data frame and get the head. Yeah, now it's given price. Okay. So price, now time is not there. So I'll have to define time also. So I'll define time here. I create a new variable called time because when you go through trend, you should have a time variable. Okay. So how I create a time variable is I use a square bracket. Within quotes, I say time. Okay. Is equal to np numpy dot a range. Okay. A range. Then I say shape. And sorry, not shape. I'll keep the same thing. Dot shape. Okay. And I'll put up square bracket. And I say 0, that means the first term. So whenever I say shape, I will get a row and a column. Okay, I'll just do that. Just want to see what it is. If I say shape, no? If I say shape, I will get 542 rows and 1 column. If I say shape 0, I will get only 542. So I want the series to run from 0 to 542. Okay, so that's what this accomplishes. And now it will give me all of this together. So it's giving me the date, which is in the index. It is giving me it's monthly. You can see that 12th month, first month, second month, like that. Time is also there. Now I'm going to fit this thing on time. Now it should work. It should work. I just run it. So this is my regression. Fit is R squared. R squared is so much. So if I have to write the regression, now this is the trend. The trend in exchange rate from the beginning year to the end year is if I write the trend, it will be written as I just show you. If I write the trend, I will write the trend as trend is equal to this constant plus the regression coefficient. That means it's increasing by 0.1382 rupees per dollar every year. Time. This is your trend equation. So this is the rate it's increasing. It is it is significant, highly significant. So there is a trend. There is a trend in the series. Okay. So let me just plot that series. Right. I'll say PLT dot plot. Right. Since the date is an index, so no problem. I just have to plot the price. Okay. I just plot the price. Done before, but I'm doing it with a very specific purpose. Okay. So I will put the price and there. So okay, there it is, price. But that's not all. So I will also say plot. Now the model is called the model that we fitted. We called it model, not trend. We called it model. Okay, we can see this is the model. So let's say model dot in the model dot preset. Okay. Yeah, there you go. I agree. Yeah, so he says X rate index, he's put the index, price, original, he's give me the whole words. So we will get right. There you go. So look, so easy it has become. It has become really, really easy for you guys. Now I'll take this out. I just asked the computer what is the mistake I made, and it not only gave me the computer, it also gave me the regression. Right? It says that this is the trend in the series, which is captured by this trend equation. It is increasing from 4.5. It is increasing all the way till at the rate of 0.1382 into the regression. So this is the trend. So this is the trend. So it is not harmonic regression. It is trending. Data versus it is not trend. trend. So there we go. So you got estimated trend. You know at what rate it's going. So if you're going to make a long-term forecast on the exchange rate, you should forecast the trend. You should forecast the trend. Okay, you should forecast the trend beyond this. Okay, so maybe a little, it's gone up much more than the trend. So the exchange rate has gone up much more than the trend, which is not a very healthy thing. You know, it is on the trend all this time, and then now it's gone, it's got currently devalued, which is not a very good sign, right? So there we go. So you got the trend. Now you got the seasonal component. So now you know the trend. Here it is. We know the trend. We know the seasonal component. What's the seasonal variation? Now we want to know, I want to combine both of these and get a forecast. I want to combine the trend. So for that, we use a model called the Holt-Winters model, which I've already explained to you. So here I will take the price. I'll again resample, make it monthly, and I will interpolate the missing values. And here it is. The model is, it's called again model. It is called exponential smoothing. I'm using the additive model. There is a, I told you, there's an additive model. The seasonal period is 12 because it's monthly data. And I'm forecasting for the next 12 months and I'm plotting it. So here we go. Okay. And we plotted it and that's what we did. Okay. So it is, this is the Holt-Winters model. It, by default, it decides what the components are. By default, it decides what the components are, the values of alpha, beta, and gamma, and then gives you a forecast. Now, how do you get the forecast? Here it is. He's forecasted it here. Forecast is equal to fit. He's taken the fit from here and forecasted for the next 12 months. And when I just ask for forecast, it gives me the values of the forecast for the month of February, because data is up to January, February, March, April, May. So we have just finished May. We get a value of 86.6. Okay. So we'll just check what is the value right now. Okay, we'll just say INR USD. Okay, USD 85.39. You get some value. I mean, you can get it from the net. So you can get it. 85.38. 85.38 is the exchange rate. So we'll go there. 85.38. So we're not bang on. 85.38 is 86 point. Oh, so 83.84. That means it's roughly $1. 85.38 is what we get. Little more than $1. $1.2. It is overestimating. It's overestimating. But what we look at is we look at the trend and we say that the prices are likely to go. Okay, they're likely to go. So it's not as if we can get the correct value. So this is how you do a Holt-Winters forecast. So Holt-Winters model is a very powerful model for forecasting time series data. It combines both the editor. So we have decomposed the data and we've also worked out the Holt-Winters model for forecasting. To discuss the multiplicative model, more or less in the same lines as the additive model of the Holt-Winters model. When you have a multiplicative model, as we discussed earlier, there all the terminologies are multiplied. The trend into seasonal, into cyclic, into irregular variation. So just showing you how the multiplicative model is there. So we just say exponential smoothing is for Holt-Winters model because it's triple exponential smoothing. This is the data. And here, instead of trend, there we put as add. There we put as for additive. Here you just change it to MUL for multiplicative. Seasonal is additive. Trend is additive. Seasonality is multiplicative. And the period is 12 because we are using monthly data. And then I ask, because we call it model, and then I say fit. Optimization is true. Optimize true for better parameter estimation. Because what you mean by parameter estimation is it will estimate the values of alpha, beta, and gamma. And then I forecast it for the next 12 years, just the same way they have done. And then I go in for a plot. So first, get the model itself. Okay, we get a model. So it starts with various values. And finally, it comes to the level value 1, which means I take the most recent level. Trend, it's taken almost 0, which means it divides it over the entire period. And so also it has taken the seasonality 0, it's taken a value parameter gamma, alpha, beta, gamma, which are taken. And then finally, based on that, the forecasts have been prepared. So we get a look at the forecast, we get the multiplicative forecast, and we get a value of for May of 86.91. 86.91 whereas for the additive it was 86.60. So slightly higher, but the actual value, as we know, is slightly lower. So that is likely to happen, but it is very close. So with that, so that explains the time series decomposition and how it is used in forecasting using the Holt-Winters model. So Holt-Winters model is also a very effective model. It has two types. One is a multiplicative and additive. And this demonstration will help you to understand what it's all about. Thank you.